Good morning to one and all. My name is D. Naresh. My topic regarding to the electrical power transmission system subject is development of underground through soil wireless acoustic communication system, which is nothing but that of here the technology regarding to the wireless acoustic communication system in the underground should be increased, and it would be increased. Here the abstract of the here abstract of the subject wireless underground sensor network WUSNS are networks of sensor nodes operating below the ground surface which are envisioned to provide real-time monitoring capabilities in the complex underground environments consisting of soil, water, oil and other components. In this paper, we investigate the possibilities and limitations of using WUSNS for increasing the efficiency of oil recovery process to realize these millimeter scale sensor nodes with antennas at the same scale should be deployed in the confined oil reservoir fracture. This necessity the sensor nodes to be operating in the terahertz range, and the main challenge is establishing reliable underground communication system which despite the hostile environment which does not allow the direct use of most existing wireless solutions. The major problems are extremely high path loss, small communication range, and high dynamics of the electromagnetic waves when penetrating through soil, sand, and water, and through the very specific crude oil medium. The objective of the paper is to address these issues in order to propose a novel communication channel model considering the propagation properties of terahertz electromagnetic waves in the complex underground environment of the oil between nodes for different water, crude oil, carbon dioxide composition. Next, the introduction as defined in WUSNs are network of wireless sensor nodes operating below the ground surface compared to the current underground sensor network which we use wide communication methods for network deployment. WUSNs have advantages in the timelines of data, ease of deployment and data collection, concealment, reliability, and coverage density. As a natural extension to the well established wireless sensor networks paradigm, WUSNs can be deployed to operate in underground tunnels and mines. In the future, they are also envisioned to provide real-time monitoring capabilities in new challenging underground environments such as soil medium and oil reservoirs. Here, the extracting information in oil recovery. Here, the oil recovery is a very complex process, and since a lot of effort and resources are involved, it is very important to have such a information as possible about the oil recovery reservoir or field at each stage of process. Thus, researchers have been looking for different innovative ways to address the question of extracting information about the state of resources from the hostile underground oil environment, where the study of progress of carbon dioxide in oil reservoirs using ultrasound and the powerful ways of monitoring the position of carbon dioxide as well as visualizing the reality of the oil producing area. The work reports results from different experiments related to the investigation of acoustic waves properties in different media. Here we can see a figure which tells the underground oil reservoir where the uppermost part of the refinery is usual is the main construction body of the oil reservoir where it took out the crude oil which is present in the underground in the form of bad part. We can see underground wireless sensor, underground sync sensor, above ground gateway, and else. Here, using WUSNS in oil recovery process, compared to the above mentioned methods and techniques, the use of WUSN for oil reserve exploration is a very new and promising trend. However, due to the extremely high path loss, small communication range, and high dynamics of electromagnetic waves, when penetrating the soil, water, and crude oil medium, most existing wireless solutions are inapplicable. The oil recovery field presents an underground environment which is much different from the ones studied in the works mentioned above. It contains, besides soil with different degrees of moisture, large amount of crude oil as well as carbon dioxide, additionally injected in the fracture during the oil recovery process. That's how the using WUSNS in oil recovery process is to be done, and it tries to decrease the effort of man work. That's how it is easy to do the process of refinery of the oil. Here, the absorption loss for electromagnetic waves in water, crude oil, carbon dioxide, and soil were being listed. In this section, the absorption properties of the different components comprising the underground oil reservoir environment, namely water, salty water, crude oil, carbon dioxide, and soil, are examined in detail and respective absorption loss. Graphs as a function of the frequency are derived as a result for each component. The suitable transmission window for wireless sensor nodes operating in the terahertz band in is determined. Here, based on that, we understood that how absorption losses for electromagnetic waves in water, crude oil, carbon dioxide, and soil. Here the losses were different in different kind of medium. When we change the medium into the atmosphere, it was different from the other medium, which is nothing but either water or else ground. As same like that of it was I mean the absorption losses were different in different medium. At last at last we understood that how actually the development of wireless sensors in the underground, which impact upon the w- working process of our mankind. Here how it impact in the working process of not only in mankind but also the efficiency of the working process. Therefore, the conclusion of this topic is, in this paper we have addressed the subject of electromagnetic based WUSNs communication techniques and studied the question whether they can enable efficient communication in complex underground environments. Accordingly, we have determined a suitable transmission range in the terahertz band, which is optimal in terms of the absorption losses of different ingredients comprising the complex underground oil reservoir environment. Furthermore, a comprehensive channel model is proposed for electromagnetic waves based WUSNs operating in mixed crude oil, either or soil, water, and carbon dioxide medium. That's how actually the development of wireless sensors in the underground, which is nothing but in the soil, impact upon the working process of either refinery, oil refinery management, or some either another process of working. That's how it impact upon the other. Thank you.